Welcome to Cloud AIOps Hub, the channel where we break down complex platform engineering concepts into real-world analogies. All right, so if you're just jumping in, we did a whole video on the setup for this. The link's right down in the description, so you can catch up. Today, we're getting to the really good part, the part that matters most, the switch and the rollback. Seriously, by the time we're done here, you're going to look at rollbacks not as some scary emergency, but as a feature, something you design right into your system from the get-go. So let's just be real for a second. Why are deployments so incredibly stressful? You know that feeling, right? You hit deploy and then you're just holding your breath, staring at the logs, just praying nothing goes sideways. And if it does, why does rolling back always feel like this mad scramble, this all hands on deck panic? And that brings us to, honestly, a pretty hard truth. If your rollback plan is just, redeploy the old version from scratch, then your system isn't actually safe. It's not designed for safety. It's built on hope. And let me tell you, hope is not a deployment strategy. This right here, this is the fundamental difference in thinking. Most teams, they push out new versions and, yeah, they hope for the best. But when you start thinking like a platform engineer, you stop hoping and you start designing. You design traffic switching systems that make deployments predictable and, dare I say it, kind of boring, in a good way. And that quote just nails it, doesn't it? And that is why rollback feels scary. It's scary because it's an afterthought. The difference between that fear and a calm, controlled process, well, that's the jump. That's what separates reactive DevOps from proactive platform engineering. Okay, so to really get this, let's step away from the code for a minute. We're going to use an analogy. I want you to imagine you're the manager of a super popular restaurant, and you have two identical kitchens. You've got Kitchen Blue, which is your trusted current kitchen, and Kitchen Green, a brand new, shiny one you want to switch over to. So here's how you, the smart manager, handle this switch. First, you're not just going to open the new kitchen to everyone. No way. You test Kitchen Green through a side entrance. This is your internal team, your trusted tasters, making sure everything's perfect. Once you get the thumbs up, you go out to the front door and you flip the main sign. All new customers are now directed to Kitchen Green. But, and this is so important, you don't just tear down Kitchen Blue. You keep it warm, ready to go, just in case. And what do you know? A complaint comes in. Someone's dish from Kitchen Green isn't right. What do? You just calmly walk to the front door and flip the sign right back to Kitchen Blue. And what was the result of all that for your customers? Absolutely zero downtime. The people who hadn't ordered yet, they were just seamlessly sent to the old, reliable kitchen. They never even had a clue there was a problem. That is what a well-designed rollback feels like. Okay, that was the easy part, the story. Now, let's get back to reality. How do we take that simple restaurant idea and actually build it in AWS with our Terraform code? It actually maps almost one-to-one. That front door sign, that's your main production load balancer listener, the AWS LB listener.prod on port 80. The side entrance for testing, that's a whole separate listener, AWS LB listener.test, on a different port like 8080, pointing to your new green environment. Redirecting the sign is literally just updating the default action on that production listener to point to the green target group instead of the blue one. And flipping it back, you guessed it, it's the exact same update, just in reverse, pointing traffic right back to blue. Now, to pull this off in Terraform without it fighting you, there are two little tricks of the trade you absolutely need to know. First is depends on. This just makes sure Terraform creates your listener before your ECS service tries to connect to it. Simple, but crucial. Then you have the lifecycle block with ignore changes. This one is the real hero. You're basically telling Terraform, hey, I know our deployment script is going to change which target group this listener points to. Don't freak out. Don't try to change it back on the next apply. This is what lets our switch stick. Just stop and think about that for a second. The entire act of deploying a new version to all of your users is one single Terraform change. And the rollback, the thing that used to cause panic attacks and 2 a.m. calls, is also just one Terraform change in reverse. It's just as fast, just as simple, because that old version was sitting there warm and ready the whole time. Now, it's really important to be clear here. What we're building in this lab with Terraform is the rock-solid foundation. This infrastructure is what makes safe switching possible. The next step, the full evolution, is to automate this whole dance with something like AWS Code Deploy to handle the testing, the traffic shift, and maybe even automatic rollbacks based on alarms. So when you zoom out, what have we really talked about? This isn't just a cool new pattern or a trick with a load balancer. It's a fundamental change in mindset, a different way of thinking about our job as engineers. And this is really the heart of it all. We're moving away from just pushing code and hoping for the best, and moving towards designing systems that can move production traffic safely and predictably. You're not just a coder anymore, you're an architect of the delivery platform itself. That is platform engineering. And that is a wrap on our ECS Blue/Green series. If this helped you understand zero downtime deployments in a new way, subscribe to Cloud AIOps Hub for more platform engineering breakdowns.